Do subscribe to Ekeeda channel and press bell icon to get updates about latest engineering, HSC and IIT JEE main and advanced videos.
Hello students, let us solve the next question. Question number 6 of JEE Advanced Physics paper 2017. Friends, let us solve question number 6. It says that in circuit shown is LCR circuit, L inductor, capacitor and resistor having L is 1 micro Henry, capacitance is 1 microfarad, resistance is 1 kilo ohm. They are connected in series with AC source V equals to V naught sin omega t as shown in figure. Which of the following options are correct? The current will be in phase with the voltage if omega is this. The frequency at which the current will be in phase with the voltage is independent of R at omega is approximately equal to 0. The current flowing through the circuit becomes nearly 0. At omega 10 raised to 6 greater than 10 raised to 6 radian per second, the circuit behaves like a capacitor. First of all, in this LCR circuit, we know that the current, it talks about the current is the V divided by Z, which is V divided by XL minus XC the whole square plus R square and under root. This is the formula for the current. Now, XL minus XC the whole square, and we know that XL equals to omega L and XC equals to 1 upon omega C. Now, this is the value and the current will be in phase with the voltage. The current and voltage will be in phase only when these two will cancel out. These two will cancel out. So, for these two to cancel out, if the omega is this, that we have to check whether it is true or false. If for option number 1, I will say that for I to be in phase, with voltage V, XL should be equal to XC. This is the condition. If XL is XC, then I'll write that omega L is 1 over omega C, or omega square is 1 upon LC, or omega is 1 upon LC under root. Now it says that omega is this, but let us find what is the value of this. LC is, L is how much? 1 mu h, and C is 1 mu f. And if I take the under root, then what I will get? Under root of this, then this is 10 raised to minus 6 Henry, and this is 10 raised to minus 6 farad. So that is equals to 10 raised to minus 6. So this comes out to be 1 divided by 10 raised to minus 6, which is 10 raised to 6 radian per second. So that means the current will be in phase with the voltage when omega is 10 raised to 6. But in the given question, it is saying omega is 10 raised to 4, which is not right. It should be 10 raised to 4. So this option is not right. The second one, we'll choose the second one. Let us solve the second part of this question. The second option says that the frequency at which the current will be in phase with the voltage is independent of R. So current to be in phase with the voltage, the frequency should be independent of R. So you can see from the expression that we got omega is this one. So whatever the frequency, so for I in phase with V, the omega expression we got 1 over LC root, or if you talk about frequency, 2 pi f is 1 over LC root. So this frequency is 1 over 2 pi under root LC. You can see that this frequency is independent of R. You can see there is no R present in the expression, so frequency is independent of R or resistance. So the frequency at which this takes place is independent of R, so this statement is correct. Is independent of R. Next part is we'll check this option. At omega approximately equal to 0, the current flowing in the circuit becomes 0. If omega is 0, whether current is 0. So to do that, I will check for the option number 3, omega nearly equal to 0 radian per second. What about the current flowing in the circuit? So the expression for I is again is V divided by XL minus XC the whole square plus R square under root. If omega tends to 0, then we know that XL is equal to omega L and XC equals to 1 over omega C. So omega tends to 0 implies XL tends to 0 and XC tends to infinity. XC tends to infinity. If this tends to 0 and this tends to infinity, so the whole thing tends to infinity. This term will tend to infinity. So that implies Z tends to infinity. If Z tends to infinity, then I is V by Z. If this tends to infinity, then I tends to 0. So that means at omega approximately equals to 0, the current in the circuit becomes nearly 0. That is correct. It is 0 because it tends to infinity, it tends to 0. That is correct. Next is that for the option number 4, let us solve the option number 4. It says that at omega greater than 10 raised to 6 radian per second, much greater than that, the circuit behaves like a capacitor. Omega increases. Here we have the expression for omega, which comes out to be 1 over LC. We know that this comes out to be 10 raised to 6. This comes out to 10 raised to 6, at which the circuit is I is in phase with voltage. But then omega influences the inductive nature or capacitive nature of the circuit, because as omega increases or decreases, that changes the value of XC or XL. XC is 1 over omega C and XL is omega L. That implies that XC is proportional to 1 over omega, and here XL is directly proportional to omega. So as it says that the option number 4, it says that omega is much greater than 10 raised to 6. So if this omega goes beyond this value, much greater than 10 raised to 6, then if this increases, then this will decrease, and if this increases, this will increase. So in the difference of XL minus XC, or in the phasor diagram also, in the phasor diagram, this is our R, this is our XL and XC. In that form, if XL increases and XC decreases, this will keep on decreasing. So the net value will be XL. Net value will be XL. So it will be in this side, and therefore the circuit will be more like inductive circuit, because it will dominate the circuit. Because XL is greater than XC, So the circuit will be inductive in nature. Circuit is inductive. So therefore, if the circuit is inductive, this is not right. This is like a capacitor is wrong. The circuit behaves like inductive circuit. It is not capacitive circuit. So these are the two answers to these questions. Okay. Thank you.